Hi, I think you are doing well. So, in my last video, what I told you that we will reproduce this model actually. This is a temperature sensor. Okay, so we'll reproduce this model actually right now. We'll start it. So, for that, we need some parameters value of this sensor actually. So, here you can see this is a elliptical shape. Okay, and um, two different kind of air hole. Okay, so right now what we need actually we need the okay the diameter of two different air hole and the piece and as well as uh, the diameter of small axis and large axis. Okay, so here you can see that d1 is equal to 1.6 mu. Okay, I don't know what is mu here. Okay, we'll check actually. Don't worry. And d2 is here, and piece is here. Okay. Oh, okay. Micrometer. It's micrometer actually. They just make it separate. Okay. Don't worry. So, okay. So, okay. So b is equal to okay. We got all the parameters maybe, right? So now we can start to just draw this model. Okay, so let's start. So we open COMSOL file. So when you open COMSOL, then you will get this kind of interface. Okay, so then you have to start from model wizard. Okay, from model wizard, what we have to select? We have to select 2D. Okay, after selecting 2D, we have to select electromagnetic wave frequency domain. So where you can find the electromagnetic frequency domain from optics, wave optics, and then you will get electromagnetic wave frequency domain. Okay, then you have to add it from here. Okay, or double click. Just you can double click, then it will add automatically. Then you have to select study. And then what we have to do, we have to select mode analysis. So double click here or just you can click done. Okay. So when you will click done, then it will just bring us the main interface of the console. Okay. From here, we have to just import the parameters file at first. So from parameters file, what we can do here, you can see that we have to import D on D2. Okay, at first I will choose piece. Okay, so piece is equal to 2.3 micrometer. Okay, so piece we can write a P as P 2.5 micrometer, right? Micrometer Okay, 2.3. I'm sorry, 2.3 micrometer actually. Then D on is equal to actually 1.6 micrometer. So it is 1.6 micrometer. Okay. Then D2 is equal to actually 0.8 micrometer. 0.8 micrometer. Okay. Then A and B. A is equal to 1.2 micrometer and B is equal to 0.8 micrometer. A is equal to 1.2 micrometer and B is equal to 0.8 micrometer rate. So then what we need the thickness of gold and the thickness of the upper layer, maybe it's silicon dioxide. Okay, so we need that to also the golden part on the most side. Okay, can do so piece of metal layer with the thickness. Okay, so the thickness of metal layer is M1 is equal to 70 nanometer, and the open loop silicon dioxide thickness is actually 20 nanometer. Okay, so the thickness of gold is 70 nanometer. TZ this is equal to uh, sorry 70 nanometer. Okay, and TSiO2 actually TSiO2 is equal to actually 20 nanometer, right? That's okay. So we just import all the data of geometry. Actually, right now what we can do, we can just start our geometry drawing. Okay. So from geometry, actually, I prefer to choose micrometer. So here is micrometer. This is micrometer, and okay. So from geometry, we'll start from. Okay, so they didn't mention the main geometry of the model, but we can imagine actually. So here, for this model, actually, this is hexagonal shape, right? Oh no, this is a circular shape or hexagonal shape. I don't know. Uh, it's pretty much confusing, right? Here, actually. So I don't know what the shape of this model actually. Uh, okay, it's not hexagonal. But this thing is showing that it's hexagonal, this one as well, but this part is kind of circular, right? So I don't know, there actually things, so we have to read the paper actually to understand the shape of the model actually. So we can read. Okay, so here D-shape elliptical open. Okay, I can loop diameter, first layer, circular earhole, diameter of the first layer. Okay, okay, they didn't mention actually. So it's tough for us to understand the things. But we don't have nothing to do actually. We just maybe try to create the model actually. Okay. Now what we can do, just we can draw the center circle. Then we can draw this one and then this one. Okay. Then we'll just draw the circle of this part, and then we'll duplicate. Sorry, mirror the circle actually. Okay. So that is our actually plan. So at first I will draw the circle of center. Maybe it's D2. So it's actually big here hole, maybe the diameter of D2 actually this is I'm not sorry, the diameter of big ear hole is actually D1. Okay, so uh, this is actually radius, so we have to select as D1 divided by 2. So okay, it's okay. Then we'll duplicate it. So we'll draw this circle. Okay, so if this one is centered, then the distance between these two circles is actually piece. Okay, actually the piece. So the diameter of this circle will be D2 actually, and the distance from center to center is actually the piece. Okay, so there you go. We got the circle actually, center, small circle. Then we have to draw the big circle. Okay, then we can actually again duplicate this circle, and then we just actually p into 2. Actually, the distance between this circle to the upcoming circle is 2p actually. Okay, just zoom out. So this is the big air hole. So what we have to do, we have to just okay, we have to just right now we have to draw this circle. Actually, we have to draw this circle. So if we draw this, okay, we can draw this circle actually. It's a pretty easy. Okay, so let me see. So okay, to draw this circle, actually, what we have to do, we can use actually array. It's pretty much easy. Okay, so it will be linear. So maybe we can use three linear array. So the distance of that circle will be, let's see. Okay, the position of this circle actually, it's from center. Um, oh, sorry. From this circle actually, from this circle, the position of this circle is actually from x direction is equal to minus is divided by 2. It means p by 2, and we have to know the direction of in the axis of y, right? So for y direction, the position is actually okay. This is actually p, and this is p by 2. So this one actually will be root over 3 divided by 2 into p, right? So we have to write that. So for x is equal to minus p by 2, and for y it will be sqrt square root 3 into p divided by 2. So let's see. So here you go. We got the three circle. Now what we have to do, we have to mirror the things. Okay, from mirror, we have to mirror this 3. Okay, so and you have to click here, keep input objects actually, then build selected. So we mirror in actually y direction. Oh, sorry, x direction. Then we have to mirror it in y direction. So again, duplicate it, and we have to select this one, this one. You don't need to select this two. Okay, then sorry. We have to duplicate in y direction, right? So we have to write it one. Okay. So there you go. We got the duplicate air hole in y direction. So now what we have to do, we have to just draw this circle actually. For drawing this, okay, let me see. For drawing this circle actually, what we have to do, we have to select the piece actually to P. Okay. So, okay. So we can just duplicate this circle actually. Duplicate. Oh, not disable actually, sorry. Enable. So we have to duplicate it actually. Duplicate, and then the radius is d on divided by 2. It's okay, and then it's actually in y direction. So control X 0, control V. Okay. Oh no, sorry, control minus V actually. Okay. So here you go. Here you can see there's is exactly the same as the paper actually. Okay. Okay. The position of this circle actually 2p. Okay, and then we have to delete some circle actually from here. So we have to delete entities. You have to select delete entities. From boundary, you have to select domain, and you have to delete this three circle actually. So here you go. We got the structure of air hole. Now we have to draw the elliptical shape. Okay, you have to draw the elliptical shape, and the position of the elliptical shape, I can tell you, the position of the center of the elliptical shape is actually P. Okay, so what you have to do, from geometry, right click, and you have to select ellipse. Okay, then from ellipse, A is equal to A, and B is equal to B, right? A is equal to A, and B is equal to actually B. and the position is minus P, right? Okay, from center. Here you go. Sorry, position from center. Okay, so build selected. Here you go. It's perfect, maybe. Oh no, it's not perfect. It's actually B. It's actually A. But here you can see it's not that much slurs as the paper. Okay, so a segment. I don't know how it's working. Okay, segment is equal to maybe 2 into A. Y segment is equal to 2 into B, maybe. Okay, it's not working well. Okay, maybe I got wrong. A is equal to 1.2 and B is equal to 0.8. Let me see. A is equal to 1.2 micrometer and B is equal to 0.8 micrometer. I got it right? A is equal to 1.2 and B is equal to 1.8 micrometer. But what has happened with it? I don't know. Okay, but it's small. It's not the same as the paper actually. Okay, it's not the same as the paper. Okay, let me see. Elliptical air hole. Okay, long axis of elliptical air hole is actually 1.2 and short axis. Let me see up there. Model. Okay, here you can see that it's from this to this. Okay, no, it will come. It must come like this. Okay, that's okay. No, it's not okay actually. It's not okay. Maybe they mentioned wrong, or I don't know why it is. I wrote it right. I think so. But in the model, it's not showing okay. I don't know why. Sometime maybe they did some typical mistake. Um, I don't know actually what's the problem here, but yeah, it's not working actually. That's the thing. Okay, it's not working. Okay, so what actually we can do right now? Mhm. 0.8 and 1.2. 0.8 and 1.2. Maybe, I don't know actually. Let me see something in the, uh, okay, B is equal to 1.2. Okay, confinement loss for, okay, this is D. Okay, let me see actually. What did, okay. Here you can see that they mentioned that the B is equal to 1.2, 1.6, 1. B, okay, 1.6 as well. And okay, let me just uh, figure name is 7. Okay, as they mentioned figure 7. Figure 7, when the long axis on elliptical air hole at the loss, okay, the resonance wavelength will increase with the long axis. So mhm. I'm pretty much sure they just mentioned in the paper wrong. Okay, so we may try to just uh, um, we may try to just uh, feel it like it's okay. Um, I don't know, but we have to try that if it we can just correct it. Okay, so we can build it. Okay, maybe right now it's maybe okay. I don't know, right? So as you can see, this is kind of till the um, center, right? But yeah, you can see it's not in the center, but yeah, uh, it's kind of similar. Not 100%, but yeah, kind of similar, right? Because as I mentioned you that um, it's not working like they mention. Okay, it's not working like they mention. So I don't know what's the reason, but yeah, in our case, it's not working like that they mention. So uh, I don't know their things. Okay, so it could be two if we just try to make it perfect. Uh, I am just trying to make it perfect. I don't know what's the perfect for their case, but I'm trying. Uh, okay, so let me do that. Okay, it's kind of looks perfect actually. I don't know actually. So then we just try to make it as like a paper. We don't know what's the things actually they mention, but they are mentioning parameters are not working as they actually draw the model. Okay, okay. Then we can draw. Okay, then we can just cut the model from here. So they didn't mention the height actually. We don't know the height actually, but we can guess actually. Okay, so to do that, first of all, we have to just draw a circle actually. Okay, so this is 2p. So the radius of circle will be 2 into p. Okay, maybe 2.5 into p. 2.5 into p. Okay, it's okay. So yeah, it's working. Okay. So then what we have to do? We have to cut from here. Okay. So for that we have to select a rectangle maybe. So in rectangle, what you can do? We can select, okay, I don't know right now. Okay, so from corner, not from corner, from center. Okay, so we have to select width and height. So height is not that much necessarily, but we have to select width perfectly. So we can select it as 15. It will work maybe. So uh, instead of 15, we can select it as 2 into p. Okay, it will work. Sorry, not 2 into p, 4 into p. Okay, sorry, 4 into p. Okay, okay, not 4 into p. We may select 5 into p. Okay, now it's pretty okay. So the position of the rectangle will be 2p maybe. 2 into p. Okay, let's see. No, 2, not 2 into p, maybe 1.5 into p. I don't know. Okay. It's pretty okay, I think. Um, maybe you can write it 1.6 into p. Okay, I think it's kind of okay as the paper. Okay, here you can see the distance. We are trying to read it like this. Okay, then what you have to do from geometry, you have to select convert to curve actually. This one and this one, then to make it curve, and then you have to select delete entities, and then you have to select this one, this one, this one, well as this one, this one. Okay, you have to select all of this. Okay, and then build. We just cut down the um, other things. Okay, uh, then we have to just select convert to solid, and then we can select this one and then build. So yeah, we select it. We just make it a D shape. Okay, now what we have to do, we have to just draw this curve. Okay, they also didn't mention the radius, the um, A and B of this ellipse, but we may guess that um, the actually uh, lower axis and upper axis is the same as this ellipse. Okay, so okay, we just duplicate this ellipse actually, and the position of this ellipse will be the same position of the rectangle. Okay, so Control C, and you can paste it here. Okay, but from center it's okay, but it may be uh, Control C, so minus Control B divided by 2. Okay, it's perfect, right? As the paper. I don't know, but yeah, maybe it's perfect, but we can make it 2.5. Okay, it's okay. I think it's okay. Yeah. If you don't want 2.5, you can write it 3. Actually, I don't know. Actually, they didn't mention anything. That's why I'm trying to make it trial and error. Okay, then duplicate this one. Then after duplicating, you have to select it as okay. You have to make it A plus TG to make it gold layer. Oh, sorry, what we did. Okay, so what's the value of TG actually? Value of TG is 70 micrometer. Are you sure? 70 nanometer actually. I'm sorry, it's 70 nanometer. In paper, they actually mentioned 70 nanometer. I actually wrote it wrong. Okay, so there you go. And for B, actually, TG. Okay. Okay, here you go. So you can see that it's working perfectly. And then you can duplicate this one as well. Okay, for the silicon dioxide plus TSiO2. Okay, plus TSiO2. Okay, so we also make the silicon dioxide. Okay, now what we can do actually, uh, we can just maybe different. Okay, don't need. Okay, uh, don't need to do anything. We can just do it conversion to cut. It's easy, pretty easy. Then other things. Then you can select. Let me do it. Sorry, just select this one and select these things. Then build. Then what we can do? We can just select delete entities and then just zoom in this part. Okay, then what you can do, just you can select this one till this thing. Okay, okay, maybe we have to do it more. But the problem is you don't need to delete. Okay, I don't know. Okay, they delete it. So you have to delete this one as well. But you don't need to delete this one. deselect, so this one as well, and as well here. You don't need to deselect these two things, okay? So now we can build it. Okay, there we go. Then we have from geometry, you have to select convert to solid. Okay, then select this one and build this one. It's converted to solid. Okay, so here you go. We made it. Okay, I'm sorry. I don't know what's happened, but let me see. So, oh yeah, it's okay. Top layer is actually silicon dioxide and the thinner layer is actually gold. Okay, as they mentioned, uh, open ellipse metal layer with 70 micrometer and 20 micrometer of silicon dioxide. But in their case, I don't know what they mention and what they draw. It's not the same thing actually, but mm, here you can see. They mentioned that the thickness of this layer is actually 20 nanometer and the thickness of this layer is 70 nanometer. But here they show differently. It looks like 70 nanometer, it looks like 20 nanometer. I don't know what they did. But we draw as their paper showing actually. So I don't know. If it's wrong, we will change it actually. Okay, that's the thing. Okay, I don't know right now what they're mentioning and what they are just doing. Okay, so from material, okay, right now, okay, so not from material, right now we have to just duplicate this curve actually. So not here, from here, build all objects, and from here you have to duplicate it. And after duplicating it, you have to write it as 3 maybe. 3.5, yeah, it's working. Then duplicate it here again. After duplicating it, you have to write D1 maybe okay. So yeah, our model is ready. As they mention, our model is ready. So now we have to select the materials for the model actually. So yeah, I think this model is not perfectly reproduced because they didn't mention many things and they are mentioning the parameters are not matching with their model actually drawing model. So yeah, right now we just try to make it much perfect as their paper. Okay, so uh, in my next video I'll try to simulate the model and then I will tell you how we can just make it perfect as their paper. Okay, so till now, thank you for watching my video, and yeah, thank you so much. So you can subscribe or like our channel videos or share with your friends and something like that. Okay, see you. Bye bye.